In our lesson today, we're going to be using intercepts. You can graph a linear equation quickly by recognizing that only 2 points are needed to draw a line. It's often convenient to choose points where the line crosses the axis. The x-coordinate of a point where a graph crosses the x-axis is the x-intercept. The y-coordinate of a point where a graph crosses the y-axis is a y-intercept. The graph shown has an x-intercept of -6 and a y-intercept of 4. Now, we're going to be asked to find intercepts. To find the x-intercept of a line, substitute 0 for y in the line's equation and solve for x. To find the y-intercept of a line, substitute 0 for x in the line's equation and solve for y. So now, in this first example, we've been asked to find the intercepts of the graph 3x minus 2y is equal to 6. Now, in order to determine what the x-intercept is, we'll do that one first. You're going to substitute 0 for y. So you take this equation and determine what the x-intercept is. So in this equation, the x-intercept is 2. In this next equation, so in this equation for the graph, our x is 2 and our y is -3. So let's recap. You're going to be given a graph. They're going to ask you to find what the intercepts are. The intercept is where it either crosses the x-axis or the y-axis. In order to determine what the x-axis is in the equation, you substitute 0 for y to determine what the x-axis is. In order to determine what the y-intercept is, you substitute 0 for x to determine what the y-intercept is. In our next example, we're asked to graph the equation using the intercepts that we just did from our first example. So if you'll notice, we graphed the x and the y-intercept and plotted the line. So that's all that you'll need to do when you have been given in a graph that you're to graph the intercepts for each of those. So now, using the previous examples, we're going to do 3 practice problems. So you need to determine what the x-intercept will be, what the y-intercept will be, and graph it. I'm going to pause the video and we'll come back and check. Now, for number 1, our x-intercept ended up being -1 after we plotted a 0 for the y. Our y-intercept ended up being 5/10 or a half after you plugged in 0 in your x. And then we graphed it, so it should look similar to this. And number 2, for that equation, our x-intercept ended up being 3. Our y-intercept ended up being 4. Then we plotted them with the ordered pairs of 3, 0, and then 0, 4, as you can see in the example. And on our last, number 3, our x-intercept was -4. Our y-intercept is -8, and we plotted those points. Now, in this word problem that we have, we're going to write and graph an equation using intercepts. You're canoeing along a 12-mile stretch of river. You travel 4 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times for the trip. Give 3 possible combinations of paddling and drifting times. So in this example, we are going to use the equation 4x plus 2y equals 12, because it's 4 miles per hour when we're paddling, 2 miles per hour when we're drifting, and the total trip is 12 miles. So, first thing we're going to do is determine what our x-intercept will be. Then we'll determine what our y-intercept will be. Then we'll plot those points. So I'm going to pause the video, let you work that out, and come back and check your x and y intercepts. So now we have plotted and determined what our x-intercept is 3, our y-intercept is 6. Now, it's in your directions, it's asking you to give 3 possible combinations of paddling and drifting times. So our 3 possible points are our 0, 3, or our 3, 0, 0, 6, and again we plotted a point to where we could see they cross the axes, which would be 2, 2. So 3 points on the graph are 0, 6, 2, 2, and 3, 0. So you can either not paddle at all and drift 6 hours, here's your drifting time, or paddle for 2 hours and drift 2, or you can paddle for 3 hours, here's your paddling time, and not drift at all.